Good afternoon. We are going to calculate the relative atomic mass of hydrogen. You saw this on the previous slide. What we have here are three isotopes of hydrogen. Each isotope has a mass number as a superscript. We call that number the mass number. And remember that this is the number of protons plus the number of neutrons. What I'm going to do first in order to come up with the relative atomic mass of hydrogen is I'm going to change each relative abundance into a percentage. Essentially, I just have to, from a percentage into a decimal. Essentially, all I have to do is mentally divide by 100, which all I have to do to mentally divide by 100 is move that decimal 2 places to the left. So I have now 0.9998 and 0.002. The next thing I'm going to do is I'm going to multiply each of those decimals by the mass number. So here's hydrogen 1. It has a mass number of 1. So over here, I'm going to multiply that by 0.9998. And I get itself over again. Easy math. I'm going to do this for hydrogen 2. 0.002, and I get 0.004. I'll add that there just to make sure all the decimals are the same. The trace one, I'm not even going to throw in because there's so little hydrogen-3 in the universe that it's so unstable it doesn't add to the relative atomic mass that you'll find on your periodic table. Already on the last step. The last step is to add these things together. And so I'll add them together. And I'll get 1.0038. And my units for this are atomic mass units, which we're going to convert later on in the year to grams, which is a very simple conversion. But we're just going to leave them atomic mass units for the time being. In order to double check your work, you already have your answer key. The answer key is your periodic table, and you look at your periodic table. If you're really, really close to this number, your answer is correct. You will find the periodic table that I handed you, the number does not match. Does that mean you have to do it over? Absolutely not. It's because your periodic table is a living document, and the relative abundance of each isotope is continually changing. And since it's continually changing because we get more information, our atomic masses continually change. Does that mean you have to go back and redo everything? Absolutely not, because the change is so small it won't affect your overall work. So the periodic table that I gave you, it was hydrogen is 1.008 AMU. That's close enough. That's how you calculate the relative abundance and the relative atomic mass for a set of isotopes. Good luck.